Good morning, everybody. This is our last day of geometry notes. Woohoo! So you are going to have to do two sections. So this is the first one, 11.5. So these are all about the angle relationships in circles. So hopefully the first few are going to be pretty easy, okay? For which pictures above is the point of intersection of the two lines inside, outside, or on the circle? So if you have eyes, you should be able to do this one. So for the first one, obviously these two guys are intersecting inside the circle. So that's just going to be A. These guys are intersecting on the circle. So that is going to be B and C over here. And then for outside the circle, these guys are intersecting outside the circle, outside the circle, outside the circle. So then D, E, and F are right here. Okay, that's the first part, easy peasy. Okay, let's actually put another theorem into practice. So if a tangent and a chord intersect on the circle, so we are on the circle right here. So, and remember, a tangent is where it only hits a circle once, and then the chord would actually be going from Z to A. So this one, the tangent and chord intersect on the circle. Okay, then the measure of each angle is 1/2 the intercepted arc. So over here, it says, what is 1/2 of ZPA? So let's first figure out what ZPA is. ZPA is this one, okay? And then it says the measure of the angle is 1/2 the intercepted arc. So this is my intercepted arc over here. So 1/2 of this arc is going to be angle 1, or the measure of angle 1. And then if you go backwards, if I take 2 times the measure of angle 1, then I'm going to get the measure of the arc. So those are just going backwards of each other. Okay, and then on the other side, if I have 1/2 the measure of just ZA, my minor arc, so ZA is over here, okay, that means I'm just going to get the measure of angle 2. And then if I have 2 times the measure of angle 2, I'm just going to get back to the measure of ZA, arc ZA. Okay, so hopefully you guys can see the intercepted arc. So it's in between that point, that point of tangency, and where the point is on the circle. All right, let's do an example with these guys. Okay, so given that arc BC is 126 degrees, mark this on the picture. So we have arc BC is 126 degrees. Okay, so now it wants us to figure out what is the measure of CEB. All right, so C, got to go through E, and then all the way around to B. So if you see this, my highlighting skills are not that great, but it'll do. All right, if you see this, it's like, what did I not highlight in this circle? I highlighted the whole thing. So if I know that just this little tiny arc is 126 degrees, I know that the whole circle is 360. So if I want to figure out the rest of it, that just means I have to do 360 minus 126, and that's going to give me the measure of that major arc, which is 234 degrees. All right, now it says find the intercepted arc for ABC. All right, so ABC is this guy over here, and the measure of ABC. So if I'm trying to figure out what this angle is over here, I know its intercepted arc is this BC arc, which is 126 degrees. So I'm just taking 1/2 of that, or just dividing it by 2. So 126 divided by 2 is just 63. And then it says find the intercepted arc for CBD. So CBD is this angle. All right, and then it says find the measure of that angle. So we already said that this whole thing was 234 degrees, which means I just have to cut that in half. So 234 divided by 2 is going to give me 117 degrees. All right, and then it says, what do you notice about angle ABC and CBD? So hopefully you shouldn't even need to see the actual numbers. You should be able to just look at the pictures, but the numbers confirm it. They add up to be 180 degrees. So that means that they are supplementary. All right, so they are supplementary angles. So And it makes sense because if you're using the whole entire circle, then if you're cutting that in half to get those intercepted angles, then it's going to be 180 degrees altogether. All right, let's go on to the back page. Okay. So now I have, if two chords or secants, so the way that they're written over here, they're secants because they got arrows on the end of them, but really if you just cut them off at where they touch the circles and they're chords, regardless, if two chords or secants intersect inside the circle, then the measure of each angle is 1/2 the sum of the intercepted arcs. All right, so we need to add for this one. So, and it's 1/2 the sum, okay? So complete these equations. And for these ones, we're not going to worry about this stuff right now, the converse stuff. So we're just going to figure out how to solve for these measures. All right, so first, we're talking about angle 1. So you'll notice that angle 1 and this angle that's not marked over here, you should know that those guys are vertical angles. So what you want to do, since they're not intersecting like through the center or they're not intersecting out outside like they were before, you want to take the sum of the intersected arcs of both of them, both its angle and the vertical angle, and that's why you're cutting them in half essentially, because they're both sharing that measure. All right, so for this one, we're just going to write down, since we're not given any numbers, so we're just going to write down the arcs. So we're going to add up the measure of arcs AB, and we're going to add up the measure of the arcs TS. And then we just cut those in half. So we add up those two arcs, cut them in half. Okay, and then for angle 2 over here, now we have this angle, its vertical angles over here, so we want to add up those intercepted arcs. So we're going to take 1/2 of, oh, they already have this. So we have to take 1/2 of measure of arc AT and then add it to the measure of arc BS. And then we take half of that and that's it. Okay, so, and then what special angle pair are 1 and 2? Again, you should be able to see that. They are a linear pair or supplementary angles. Okay, so moving on to our next one. If two lines, secants, or tangents intersect outside of the circle, then the measure of the angle is 1/2 again, but now it's 1/2 the distance. So with these guys, since they're intersecting inside, we're kind of adding up these two arcs and dividing them in half to share those vertical angles. But now for these ones, since we're trying to figure out this exterior angle, we're going to take the arc over here, the bigger farther away arc, and we're going to subtract the smaller interior arc over here to figure that out. And again, we're not going to worry about, let me move this down just a teeny bit. All right, we're not going to worry about these guys over here. All right, so if we're trying to figure out the measure of angle 1, you always want to start with the bigger arc more on the exterior of the circle, and you're going to subtract the smaller arc on the interior of the circle. So with these guys, we're going to take 1/2 of the measure of AB, arc AB, minus the measure of the arc TB. Okay, same thing over here. So when we're trying to figure out the measure of angle 2, we want to take this bigger, more exterior arc, and then we're going to subtract the smaller, more interior arc, and I say interior like closer to this angle. So we're going to take the measure of AB, arc AB, and subtract the measure of arc TB. All right. And then for this one, same thing over here. So we're going to take this bigger exterior arc, but now we have to go all the way around over here. And that's a major arc. So we have to use 3 letters, and we have to fill in this 1/2. So we have the measure of arc TAB. And then we are subtracting this more interior arc of TB. All right, so one of the things that we're going to be getting to over here is, notice down here, So it says complete the equation. So if I take the measure of arc TB plus the measure of the arc TA, what are they going to equal? How many degrees did I just highlight down here? So notice that this secant line is going through the diameter, which is cutting the circle in half. So this guy is actually half the circle, which is 180 degrees. So why? Because arc TA, or I'm sorry, segment TA is the diameter. All right, so if you go through the diameter, that means your two arcs are always going to add up to be 180 degrees. And if I look at this one, so TB plus TAB, how much of the circle did I actually highlight? I highlighted the whole thing. So these two arcs together are the full 360 degrees. And why? Because the arcs complete the circle. All right, so we will stop this video over there and then we'll finish the examples on the next one.